Hello, my name is David Little. I am a data scientist here with the Unit for Data Science and Analytics at the Hayden Library at ASU. And today we're going to talk about model selection in data science. So this will be just kind of a high level overview. In subsequent sections, we will go into some of these topics a little bit more in depth. But for now, just kind of covering the highlights of how do we go about selecting a model that we're going to build in data science. So kind of first and foremost, there's an overwhelming number of models to choose from. If you are first starting out in data science, it can feel a bit overwhelming. But the nice thing is we can kind of sit back and think about the problems and think about the problem that we're approaching and think through what is the objective. So kind of where do you start really is to figure out what is my objective. There's kind of some main categories as far as selecting models. They're generally considered among these different categories that I'll list right now. It'll be supervised learning, unsupervised learning, dimensionality reduction, anomaly detection, and time series analysis. And supervised learning is really, I have a class or I have some sort of Y, my y-axis, and I need to predict it using some variables, some X's. So this is what you're usually familiar with as far as my, independent and dependent variables. Usually you cover that in grade school. You've got independent variables that you want to use to predict something that is dependent on those. So, what's the weather going to be like tomorrow based on the weather today? Unsupervised learning is really try to kind of group your data together into some distinct groups. The reason why it's called unsupervised learning is because you're not trying to predict anything. This is just how does the data look together? How does it behave together? Dimensionality reduction is very related to supervised learning in that I want to reduce the number of variables that I need to use to predict my Y. So this is when you're brainstorming, you come up with 100 different variables that could influence your Y-axis. Well, that might be a bit much. There might be a few in there that aren't very important. So that's kind of reducing that. Anomaly detection is trying to identify some value that is significantly different than others. This is very common in like cybersecurity or financial transactions, trying to identify, some weird behavior that you want to kind of call out. And time series analysis is really just volumes or things over time. You're trying to see how things trend over time with seasons, year over year. Very common in financial areas. Moving on, we kind of talked about the main categories. So once you kind of figure out the main objective, there's a whole nother layer that you just peeled back, and there's all sorts of different kinds of algorithms within those topics. So let's say I chose supervised learning. I want to predict some sort of Y. Well, guess what? There's a whole bunch of different categories within that. There's regression models, which are very common, and they're used in a lot of science. They're basically X and Y, your R squared, your classic statistics. But then there's things like classification, which you can still use to predict, but you use more along the lines of decision trees, random forests, support vector machines. The list goes on and on. How do we choose between this? The main thing is research. So getting to know the algorithms, you'll never know all the details of every single model. It's just too much. So thinking through your problem logically, looking at what other people have done with similar problems and seeing how they've approached those. So really just looking into research. Research is your best friend. Also looking into the packages, and if you're using Python or R, there's a lot of documentation within those packages that you can look into, look up what the regression model is. The documentation is pretty well defined for a lot of these package implementations. And, if you've used Python, there's a package called sklearn, which is a lot of machine learning and predictive models and things. The documentation is actually really great. The website has a lot of detailed information. So look into your algorithms, understand them. After you've kind of figured out some main goals, then you kind of want to dig into it. Experience and practice. Don't be afraid of trying different models and seeing how they work. Let me talk about parameter tuning. So after you've kind of selected the algorithm, then we want to hone in on, you have a lot of options within each of these algorithms. So there's a lot of settings. So with regression's a bad example, decision trees or random forests. I won't go into a lot of detail on this, but random forests, you can pick how many times it's going to iterate. So how many times it's going to repeat the model building process. And you can do it 5 times, or you can do it 10,000 times. And understanding that cutoff, where do you pick the value? This is kind of where parameter tuning comes into play. Again, re-emphasizing reading documentation and research. If you've picked random forests, look into what other researchers, what other data scientists have done, what they have found effective, and apply those to your model building. Another thing is there are model tuning algorithms. Hyperparameter optimization is often what they're called. Basically, some of these they repeat the same model building, just changing one variable at a time. And then you try to, optimize that. They can be very computationally expensive to do those tuning algorithms. So it may not be to your favor. Again, I fall back to reading documentation and research. It's so important. Of course, as well, we can do some guessing and checking. There's absolutely nothing wrong with guess and check in data science. It's better to get your hands dirty, to try something, to test something out and make progress and learn, rather than just sit there and say, hey, you know what? I don't know, so I'm not going to try. There's nothing wrong with testing out different ways of approaching model building and seeing how they work. So with parameter tuning, make sure you're doing your research, reading up on it. There is the option of some automatic algorithms, but they can be problematic, and guessing and checking can be your friend. And last but not least, and kind of tying back into the guessing and checking and what I was saying earlier about, trying different models, there's never a one-size-fits-all model building practice. What works for one particular data set does not necessarily mean it's going to work for all data sets. And there's certain algorithms, there's certain settings that work really well with a particular data set, and you translate that to even a similar data set and it just won't work. I've seen it 100 dozen times. It just doesn't work. It just doesn't. Each problem has to be kind of approached separately. And re-emphasizing what I've repeated multiple times already, try things out and make sure you're reading up on your documentation, and to not be afraid to try different approaches. In fact, it's very common practice in data science to take one data set and try multiple models and compare them. So, what is the performance of trying a neural network versus a support vector machine? And depending on your application, if this is a one-time analysis or if you're trying to embed some sort of model building that's dynamic, maybe a support vector machine is more accurate, but its building capability is very computationally expensive or takes a really long time, in which case you might want to try a different sort of approach that may be less accurate, but is more feasible when trying to make this dynamic. But again, just want to reemphasize, try multiple models and compare their performance. And there's a lot of packages, a lot of ways to assess accuracy, depending again on the type of problem that you're trying to do. This doesn't quite apply to the clustering because, how do you measure the accuracy of a cluster? There are some stuff out there about that, but it's a little bit easier to understand when you approach it from kind of the predictive model approach. But try 2 or 3 different model building techniques and compare their accuracy with each other and see how well they are performing. And there's nothing wrong with displaying that those findings directly to your leadership that you're working with or your customer that you're working with. In fact, I have found in my experience that, a lot of leadership really tends to enjoy those sorts of comparisons. They like to see multiple solutions and see the difference between them, and kind of gives them an opportunity to pick what they deem is the most effective. And it not only helps you, but it kind of helps the real final decision makers when trying to kind of implement these things. So again, compare your models and don't be afraid to display that information to your leadership. Again, this was kind of a very high level. We can go into much more detail with a lot of these subjects in the future. In subsequent modules and things, we will kind of go into a little bit more detail. But here's some quick links if you want to go into further detail on your own. These are some basic, some of them are GitHub repositories of cheat sheets and whatnot. And some of these are actually courses that are publicly accessible, one of them from Stanford. So feel free to kind of dig into this topic on your own and stay tuned for future modules from us that we will kind of go into a little bit more detail on each of these things. But thank you for joining us today, and don't be afraid to try out some new machine learning techniques and algorithms. Thank you so much. Bye.